Hey guys, welcome back to another Alpha Data Math Tutoring to Go IM1 video. Today we're going to be talking about key features of a graph, specifically domain and range, intervals of increasing, intervals of decreasing, intercepts, and maximum and minimum. So let's get into it. We're going to start off by talking about domain and range. We've covered domain and range in a previous IM1 video, so we're not going to spend too much time on it, but if you want a more in-depth explanation of what they are, you can go and visit that video on our YouTube page. So domain is all of the possible input values of a function, and range is all of the possible output values of a function. So these can be written in several different notations. For example, they can be written like this, where my minimum x or y value would be here and my maximum x or y value would be written here. It matters though whether or not you use parentheses or brackets. A parenthesis indicates that the value is not included. So say that my function, has a minimum of 2, but doesn't include 2, then I would use a parenthesis. But if it includes 2, then I would use a bracket. You might also see it written in a different notation. So say we're talking about my domain and my minimum is 2, like I said earlier, you might see your function written like this. Say my maximum is 3 to describe the domain. And this, similarly to how we were talking about the parentheses and brackets, your less than or equal to signs are like your parentheses, but if I were to, your less than or greater than sign are like your parentheses, but if I were to make them less than or equal to or greater than or equal to signs, then they would be serving as brackets because they're saying that it could also be equal to 2 or equal to 3, so it's including those numbers. So if we're going to look at an example of this on a graph, say I am looking at a linear function and it looks something like this. If I'm just going to throw some numbers on here, we're going to keep going with the 2 things. Say we have -2, 3, 4, and -4 here. Again, this is not drawn to scale. I'm kind of just drawing things here. So say these are closed dots on either end, and this is the function we're dealing with. So if I want to find my domain, that is all the possible input values, which you can also think of as the x values. So my minimum, clearly our function has a minimum of 4 when we're looking at just x values. So I could write that as -4. Oh, I apologize. That would be a bracket. That's an important thing to note because we're looking at a closed dot, whereas an open dot would be a parentheses. So a bracket, because it includes 4. So -4, comma, 4, because that's the max that it goes to. So we'd have another bracket here. And then if I'm trying to find my range, I would do a similar thing. So we can also see that it's a closed dot, so we'd have a bracket, and then we reach a minimum of -2. So I have -2, comma, 3, because that's my maximum y value. And then another bracket, because we have this closed dot here. And again, if it was an open dot, I'd be using parentheses. I could have a closed dot on one side and an open dot on the other side. It doesn't matter as long as you're using the correct brackets or parentheses. And say that these were arrows, or maybe just one of them was an arrow. In that case, we wouldn't have a specific number as our maximum or minimum, but rather we'd write infinity or negative infinity, depending on where it would go. So in this case, I would replace my 4 here with infinity. So it would come right over here because it would be approaching infinity. So let's replace it there. Ooh. Say infinity. And instead of a maximum of 3, we would say that our maximum is infinity because it's approaching infinity. So that is domain and range. Now we're going to be talking about intervals of increasing and decreasing. So I looped these in together because they're very similar concepts. But we're going to be using these examples that I drew here to explain what intervals of increasing and decreasing are. So essentially, let's start with intervals of increasing. So an interval of increasing would be saying that as my values of x are increasing, it describes what my output values are doing. So if my input or my x values are increasing by 1, and my y values are increasing by, say, 2 each time, then that would be an interval of increasing. Whereas if my x values, or my input values, were increasing by 1, and my y values were decreasing by a certain number, or being multiplied by a number less than 1, then I would be looking at an interval of decreasing. So for example, looking at this graph, we can see that we have a positive slope. We're looking at a linear function and it has a positive slope. So from this point to this point, our y values, or our output values, are increasing for every increase of x. So we can describe this using a similar notation that we use when we were describing domain and range. So for example, we're looking at this arrow right here, and like we said earlier, an arrow indicates that the number is going to infinity. So we can use our input values to describe our intervals of increasing or decreasing. So that would be my x values. So if I'm looking at my x values, it continues going on this way, so I would have my minimum as negative infinity, because it would continue going this way forever and ever and ever. And then my maximum, we do not have an arrow on this side. Instead, we have a closed dot, meaning that the number here is going to be included. And we can see that that number is 5, because my x values do not go beyond 5. And I would have a bracket because it's a closed dot. Okay, so now let's move on to something that is a little bit more complicated. So if we're looking at this quadratic function, we can see that it has a very different shape from linear function. So you may be wondering, like, is this interval increasing or decreasing? And it's actually both. So on a function, you can have both intervals of increasing and decreasing. Different sections of a function can serve different purposes. So we can see that from this point to this point, my graph is decreasing, because as my x values are getting bigger and bigger and bigger, we can see that my y values are getting smaller and smaller and smaller. So say that this is our origin right here at 0, 0. We can also write this. So we have an arrow, which, like I said earlier, explains that our function is going to negative infinity. If we're looking at x values. If we're looking at the y values, it would be approaching positive infinity. But when we're writing intervals of increasing and decreasing, for our notation, we'll just be explaining the input values. So we know that our minimum is going to be negative infinity. And when we're using infinity, we always use parentheses. We never put a bracket around infinity. Okay. So now you might be wondering, well, what is our maximum? Well, our maximum is going to have to be 0 right at this origin, because after we go beyond 0, our graph switches and begins to increase. So as our x values are increasing, our y values are increasing, whereas previously our y values had been decreasing as our x values increased. So our interval of decreasing, I'm going to write a little d right here, is going to be negative infinity to 0 for this graph right here. And then our interval of increasing for this graph would be from 0 to infinity. And that's it for intervals of increasing and decreasing. So another key part of a function are intercepts, and this is a relatively easy concept because there are only 2 types of intercepts: x-intercepts and y-intercepts. So y-intercepts are found where my x value would equal 0, making them fall on the y-intercept, or on the y-axis, I apologize. And my x-intercept can be found when y equals 0, making them fall on the x-axis. So if I were to write this out, if I'm finding a y-intercept, it's going to look something like 0. It's always, our x value is always going to be 0, and comma, another value. Whereas my x-intercept, we're going to have x value here, and then our y value is going to be 0, always. So if we want to look at some examples of this on a graph, we know earlier, like I said, that our y-intercept is going to be where x equals 0. So if we find x equals 0, we know that x equals 0 at this point on the graph. So then we're going to follow that down the y-axis to find this point where the line intercepts my y-axis, and that is going to be your y value. For my x-intercept, we know that that is where y equals 0. So y equals 0 along the x-axis. So then you follow the x-axis until you come across the point where the line intercepts the x-axis, and that's going to be your x-intercept. And then you would just write out the coordinate for that point to write your x or y intercept. And it's a similar idea for other functions that maybe don't look as simple as a linear function, but even if it has a different shape, it's still the same idea. And you can have more than one x or y intercept for a function. So for example, looking at this one, we can see that this function has several x-intercepts, because like we said earlier, an x-intercept is where y equals 0, and y equals 0 across the entire x-axis. And this line right here intersects the x-axis 3 separate times, giving it 3 different x-intercepts at all 3 of those points. And we have one y-intercept because x equals 0 along the entire y-axis, and the line crosses the y-axis right here. And again, we would write down those coordinates for all of our x and y intercepts. Okay, so this is a similar idea when we're looking at an equation. So I wrote out the equation y equals 5x plus 2, and we can apply a similar concept that I was talking about before. So say I have this function and I don't have a graph, but I really want to know what my x or my y intercept is. So let's start with an x-intercept. We said earlier that an x-intercept is where y equals 0. So I can set my y value equal to 0 and then solve for the equation. So I know 0 equals 5x plus 2, and then I would subtract 2 from both sides, giving me negative 2 equals 5x. I apologize, my handwriting is kind of messy. Over 5. So negative 2/5 would be my x value, which would make my x-intercept negative 2/5 or 0. I apologize, because our y value is always going to be 0 at an x-intercept. And you could apply that same concept with a y-intercept, and in that case you would plug in 0 for x, and then you would solve for y and write it out in a similar format. So that is x and y intercepts on a function. So the final concept that we are going to be discussing is maximum and minimum of a function. So looking at this graph, we can know that maximums are the greatest possible output values of a function, whereas minimum is the least possible output value of a function. So looking at this graph, we see that these arrows continue downwards forever and ever and ever. Meaning that we have no minimum, because it just keeps going and going and going for infinity. However, if we're looking at this parabola, we can see that the output values never go beyond the number 2, making our maximum 2. So if we move on to a concave up parabola, we can see that we instead have the arrows pointing upwards, meaning that the graph is going to continue going upwards and upwards and upwards, making our output values increase and increase and increase forever, meaning we have no maximum, because we cannot define that number as it keeps increasing and increasing. However, the output values never go below the number -3, as we can see on this graph, because they can curve up and go back up again. So our minimum would be -3. If we're looking at a linear function, we might see that there are closed dots on either end, and there's a specific minimum and maximum. So in this case, since we have closed dots on both ends, we have both maximum and minimum. If we were to have an arrow on either side, then we wouldn't have a maximum or minimum on that side. But since we have closed dot on the bottom here, we know that our minimum is going to be -4. And since our output values don't continue past 4 up at the top of our function, we know that we have a maximum of 4. So that is all about key parts of a function, and that is all we're going to be discussing today. But stay tuned for more Math Tutoring to Go IM1 videos, and let us know if you have any specific topics that you'd like for us to cover.